Before we start demo, just super quickly, since there seems to be some confusion on a few things about the assignment. So the first thing is that we release our test cases on Saturdays before the assignment is due. You'll get an email like this where the test cases have been released, and you can just go to the ed post and let me move myself and download this file. And once you do that, you should store it in the same folder that your app.py is in. So something like this. And then once you've done that, you can change directory to that folder that both these files are in, right? You can enter the virtual environment. And once that's done, you can run the test file. And I'm just running it on the solution code, but you should be able to see the number of test cases that pass. So that's how you run the test cases that we provide you every Saturday. So keep that in mind. And the second thing is when you're on Postman and you make a new request and you test your code with your request, make sure you save it. So let's call this create new post and let's type in the URL and change this to a post request. Even though we change this to a post request, you can see that on the left-hand side here, it's still a GET request, or it still says it's a GET request. And this URL actually isn't saved until you save it. So the way you save a request is if you're on Mac, you hit Command S. If you're on Windows, you hit Control S. Or if neither of those are working, you just click on the Save button right here. But just make sure this orange circle that my mouse is next to is gone before you submit your collection. Or oops, save. And yeah, just make sure that's there. Otherwise, we'll be removing points in future assignments. So be careful of that. Right. Hello, welcome to the recording of the demo portion that we did in lecture on Monday. This is unfortunately the third time I'm re-recording with this, but this will probably not be happening in the future very much. So yeah, don't depend on this if you've been watching lectures at home. I'll probably not be doing this any longer because I'm gonna stop using QuickTime in lecture. So all right, let's get started with this week's demo. The first things you should do is, after you've gathered the knowledge of lecture, you should know what SQL is. And the tool we'll be using that uses SQL as the main language is going to be SQLite. So the first thing you should do is download SQLite, which you can do by going to the textbook, going to the databases chapter, the pre-class to-dos, and there's a link here and instructions as to how to do so. An alternative would be just to look up SQLite download, and you can download it right here. Once you've done that, you have to restart your terminal for the changes to take effect. And once you've done that, you can run SQLite 3 in your terminal, and interface like this should pull up. So what is SQLite and how does it work? So SQLite is a tool that's built on top of SQL. It uses SQL as a base and is a tool that uses it. And it stores databases as a local file. Now, traditionally, you wouldn't do this. For any other SQL tool, you would generally have the database be stored on a server, stored online on the internet. And the reason why we don't do that for this course is because it's a bit unnecessary and excessive. To have it in a local file is enough for this class's scope, but traditionally you would have it on the internet if it's a bigger scale project. So with SQLite open, let's discuss how we start using it. So the first thing I want to show is to create a table, how to create a table. Again, tables are different containers of information. So yeah, refer back to the lecture if you forget what tables are. So let's create a table. Let's create a table that contains users. So let's call it users. And in SQL, you can write multi-line queries. And the way you do so is just by hitting return or enter like you would when you're running a command. The end of a SQL query is specified with a semicolon. So long as you don't have a semicolon at the end of the line, SQL will think you're trying to that you're trying to continue this command that you're writing, this query that you're writing. So I can actually hit enter right now and it'll ask for my next line of my SQL query. And the reason why this is useful is because we don't want SQL queries extending to like the entire horizontal span of our terminal. Just having it in vertical columns like these just make it elegant. So yeah, keep that in mind. So let's define the fields that our users tables have. So the first field we need is the ID field. This is used to uniquely identify users. And you've done this for PA1 as well. You should know why it's important to have unique identifiers for each entry in the table. And the ID is going to be an integer. It's going to be the primary key. So this basically is like telling SQL that IDs are what we're going to be using to identify different users. And we can specify auto increment. This is essentially the same thing as your post ID counter, your comments ID counter that you used for PA1. It basically keeps track of which IDs have been used and it won't reuse them again. Cool. So different fields in SQL query are separated by commas. So keep that in mind as well. But you cannot have a trailing comma. So we'll talk about what that means in a second. So each user, let's say they have a name as well, right? So in SQL, the string equivalent in SQL is text. So let's specify this type as text. Let's set a constraint for it to not be null. So you can't enter a user with no name. So let's do that. And for this table, I want to store what people's favorite boba drinks are. So let's have a field favorite boba. And let's set the type of the data. Now we've covered integer and we've covered text. Let's set it to char20. So what this means is that I can have a string of characters, but it can only be of length 20. So yeah, so that's what char20 means. And let's specify this as not null as well, because it's important that we have these favorite drinks because that's the whole point of our database or our table. And finally, let's have a favorite topping. And let's set that to just a text. Let's not put the not null constraint here. Let's say some people, some people prefer boba without toppings. You can see that I started specifying the fields of the table with this open parentheses. You will have to close it, so keep that in mind. And again, what I meant by not having a trailing comma is that I can't have a comma right here at the end of the last field. And then the way I finish the SQL query is, again, with a semicolon. So we successfully created a users table. We can check which tables exist in our SQLite 3 database by typing .tables. And you can see that the users table has successfully been created. Cool. So the next thing we'll cover is how to insert data into our database. You can review the lecture for the syntax for these SQL queries. But to insert, you would have to type insert into, and then the name of the table, so users. The fields you want to enter, so let's say for this first user, I want to specify the name. I also want to specify the boba. I want to specify the topping. And then the values I want to actually put into this entry. So let's say it's Kate. And let's say she likes Yakult green tea. And let's say her favorite topping is jelly. And then, as usual, we end the SQL query with a semicolon. So this successfully added Kate into our table. Cool. So let's just keep doing that. I'm going to copy this for convenience and add a few more entries into our table. So we just added 4 different users in the exact same way. But you notice from earlier how favorite topping isn't actually necessary to be specified. I didn't set a not null constraint. So we can actually add a user without specifying the favorite topping by just not including it as one of the fields we're specifying. And let's say Rahi likes ginger milk tea, but doesn't like any toppings in it. So we can just do that, and that works just as well. Obviously, a thing to note is if a field doesn't exist, a field that we want to specify doesn't exist. So like, let's say we want to specify someone's favorite sugar level. This is actually going to give us a syntax error, which is very nice for us because this ensures that every user in this table is going to have the exact same information, and adding a new user isn't going to add new fields. So it removes a layer of unpredictability that would otherwise have. So you can see I got an error there. Finally, if we don't specify a field that that we set as not null, SQL will complain to us. So you can see the not null constraint was not successfully met, and SQL complained to us, disallowing us from adding this entry. So you can already start seeing how databases are more advantageous than Python dictionaries, because Python dictionaries are very loose. There's no predefined data types that you can and cannot put. So there's no consistency, and that's one big benefit of databases that you all should know. Cool, moving on. Let's see how we can retrieve data from our database. So how do we check what data is in our database? So the first thing I'll show is how to retrieve all data from a specific table. So the way you do it is by typing select star indicating all, from, and then the table you're trying to retrieve information from. So select star from users gives us all the information from the users table. You can see all 5 entries that I put in earlier. Another thing you can do is specify which columns you'd like to see. So I can do select name from users, and it will only return us the names of each entry in the users table. We can separate the fields with commas to specify multiple columns that we'd like to retrieve. Right, so this gave us all the names and all the favorite drinks, but not the ID or the favorite topping. Again, if we specify a field that doesn't exist, SQL will complain to us. And yeah, this again adds a layer of consistency with our queries. Another cool thing you can do with SQL is specify conditions for your query. So let's say I want to select all users with ID 1. Now again, IDs are unique, so they'll only retrieve us one user. So let's do select all from the users table where ID equals 1. This gave us only the Kate entry in the table because that was the only user with ID 1. But we can do stuff like select all from users where favorite topping is bubbles. And this gives us all the users that has their favorite topping as bubbles, which is me and Gonzalo, the two of us. Just like in any other programming language, and, or, and not are keywords that you can use in SQL. So an example would be select all from users where favorite topping is bubbles, or favorite topping is jelly. So this gave us all the users where their favorite topping was either bubbles or jelly. Yeah, so you can combine conditions like so. Cool, so that'll be the end of demo that I covered in lecture 1. For the rest of the demo, I'll finish it on Wednesday and upload a recording of that. But again, hopefully this time there won't be any corruption, so please don't rely too heavily on these view recordings. And yeah, I'll see you guys at lecture. Okay, so we're gonna get started. So if you guys didn't see the little text edit I wrote before class, before we start, please make sure you download the starter code for today's demo if you'd like to follow along. And we have quite a lot to cover today, so I'm not going to be doing any review of what we covered last time. So hopefully, if you don't remember that, just refer back to lecture or the recording that was posted last night. So for those of you who are here, we covered creating a table, inserting elements into the table, and selecting or retrieving information from the table. So we're going to get finished with SQL stuff, and then we'll get to actually implementing this in Python code. Right, so just as a super quick recap, we created a table called users that contains users. It has a name for each user. We have their favorite boba drink and their favorite topping. And we inserted some entries, some users into our table. And then we discussed how we can retrieve this information using SQL. So just to show what we have right now, that's the information we have in our table right now. Cool. So let's move on. The next thing we'll be covering is how to update information in a table using SQL. So So let's say we convinced Kate that bubbles are better than jelly. So let's change Kate's favorite topping from jelly to bubbles. So the way we can do that is update, and then the name of our table, so users, set, and then the field we want to change. So favorite topping is a field we want to change. We make it equal to the new value we want to set it to. So we want to change Kate's favorite topping from jelly to bubbles. So let's change this to bubbles. And we have to specify a condition of where we're changing, like which user we're changing. So again, we want to specify which user we're changing using the ID, because the ID is always going to be unique. So let's say where ID equals 1, because that's what Kate's ID is. So now if we go ahead and check out what's in our users table, you can see that Kate's favorite drink, or favorite topping, has changed to bubbles. We have successfully converted her. So next thing, let's say there's this viral TikTok, and so for whatever reason, whipped cream with oat milk tea is the best drink, so that's trending. So if we want to update all our users, or actually not all users, let's say everyone who likes bubbles, right? He's doing his own thing. To oat milk tea. And we can specify multiple fields to change just by separating them with commas. So also, can you change the light real quick? Whipped cream, where favorite topping equals bubbles. All right, so very similar syntax. We're updating the users table with these specified fields and the values. And the condition is if they like bubbles right now. So now if you look at all the users we have, you can see that everyone's fields have successfully updated. Cool. And the last thing we'll cover is how to delete entries from a table. So let's delete from the table name, where, and then we can specify a condition. So we can delete from users where favorite topping is whipped cream. Maybe the TikTok became not viral and it became lame to get this drink, so everyone's embarrassed and they want to delete their accounts. But now if we look at all the users we have, it's just Rahi left. Finally, I'll talk about how to drop a table or delete a table. So let's say for whatever reason, we no longer want to have this users table. Then we can do drop table users. And we can actually specify a condition. So we can do drop table if exists users. What this does is it first checks if a user table exists, and then it drops it, as the name probably suggests. So it doesn't give me an error when I try to drop it if it doesn't exist, but if I do drop table users, it'll tell me that users table doesn't exist. So that's just a little thing to keep in mind. Now, if you remember from last lecture, you can check the tables you have with dot tables, and you can see that we have none left. Cool. And finally, to exit SQLite, you can type dot exit, which I'll show in a sec. One thing to keep in mind is in SQL, you can actually use lowercase letters instead of all these caps. But the reason why we use caps is because the caps is like SQL keywords, right? So like select is a SQL keyword, from is a SQL keyword, and users is the name of our tables. This allows us to easily distinguish the difference between which ones are SQL keywords and which ones are our table names or our field names or whatever. So if you don't do this, we will actually be docking points. If you don't capitalize your SQL keywords, we will be docking points for the assignment for style. This is to ensure that when you do write SQL code, you use caps for the keywords so that it's like much more readable. Yeah, so let's dot exit to exit the shell. Now, let's move on to the demo. So how do we implement this in Python, right? Like we know cool, SQLite saves data on our local computers in a database, but how do we actually implement this in Python code? So yeah, we'll be discussing that. Before we move on though, does anyone have any questions? Okay, great. So now let's move on to the demo. So, right, so this should be your starter code, right? Just have where your starter code lives. Let's change directory into it. Actually, you should always make your virtual environment outside your source folder, because your source folder always contains code. So let's cd out of it by one folder and make a virtual environment. I think I talked to people in office hours, but if you're having problems with Python 3 being to a new version of Python, just use Python in replacement for Python 3. So let's create the virtual environment. Let's wait for that and activate it. And oops, I didn't do that. Let's cd into our source folder and install our requirements. Also, quick little thing, we have 3 TAs present today, so if you need any help, feel free to raise your hand, and the TAs will come. We'll be running around helping you guys. So let's open this in VS Code. Okay. All right, so you can notice we have two files now, as opposed to one Python file. Previously, we only had app.py. Previously, we only had app.py, but now we have a new file called db.py. So db.py will be managing everything related to the database, which is, again, where our information is stored. So such as connecting to the database, adding stuff to the user database, retrieving, deleting, all that will be handled in db.py, and app.py will be where we define our routes, if you remember what that is from lecture 1. So let's go to db.file, and this is what y'all should see. Yeah, so just quickly what these two things in the start code mean. Singleton is this design pattern, and it basically means create only one instance of this class. If you've taken 1110 or 1112, you should know what classes are and classes and objects. And you know how for any class, you usually can create multiple objects of that class. Well, the reason why we have a singleton here is because we only want to ever have one connection to the database. If we make multiple connections to the database, and if we do it at the same time and like we write at the same time, it might actually like have some sort of like data conflicts, which we don't want. Yes. Okay, it's here. And then the database driver is the one that's actually going to be doing the connecting to the database. And we'll be continuing from our example from demo 1, where we're creating a to-do app. Cool. So let's, in our init, we can create a connection to the database. So secures a connection with the database and stores it into the instance variable con. So yeah, so when you initialize the database driver, you have to first connect to the database. So that's what we'll be doing in this init function. For those of you who don't know Python, that's when you initialize this class. So self.con, this is like a little Python syntactic thing. SQLite3.connect. Oh, wait, oops. Also, forgot to mention, make sure you import SQLite 3 up here. Okay. So yeah, SQLite 3.connect. And we'll specify again, SQLite 3 allows you to have your database in a local file. So we can specify the name of the file here in the parameters. So let's call it todo.db. That'll be the name of our database file. And we also have to do this, check same thread equals false. You don't have to worry about what this means. It's kind of beyond the scope of the class, but if you're really curious, you can either check out documentation or come talk to us after class. But make sure you do this for every single one of your apps for this class. Cool. And then the next thing we'll do in the initialize function is now that we've secured a connection with the database, we want to create a table. We want to create a task table. That's the first thing we do when we create an app, is to initialize this table, right? So let's do self.create task table, which is a function we'll. Oh, sorry. Okay, is this better? Okay, sorry about that. Yeah, please do speak up if you'd like little accommodations as such. So we'll call this create task table, which is a function we'll define now. Create task table. And in the documentation, we'll write using SQL creates a task table. Cool. So how do we run SQL commands that we just learned in Python? Oh, we can do that by doing self.con. So this is the connection that we have to our database, .execute, and then the SQL command right in here. So like if you wanted to do select all from users, right, we would type that here. So yeah, so this is going to be initializing a task table. So the way we do that is, again, the create table SQL query, if you guys remember that. And SQL commands always have to be within strings. In Python, you can write multi-line strings by having triple quotes, so very similar to what we have in our comments. The reason why we're doing this is because the create table command is usually pretty long, and having it on multiple lines makes it much more elegant to read. So we'll have a create table, tasks, let's do ID, integer, primary key, auto increment. Right, this we covered last lecture. We have a description, description, text not null. And then we have a done. So generally you would want to have done as a Boolean, but unfortunately in SQLite, Boolean isn't actually a data type. So what you want to do is store it as an integer, and 1 will represent true, 0 will represent false. So yeah, sorry that this is a little tricky to do in SQLite 3, but yeah, just keep that in mind. And then again, very important, to end a SQL query, we need a semicolon, so we can't forget that here either. Cool. Let me just format this a little nicer. Indent this a little. Okay. Now, I'm actually going to wrap this in a try-catch statement. So this, except exception, print. So if you guys know Python, what this is doing is, if whenever there's an error with this chunk of code, it'll catch the error and print out the error message. So this is like if the initialization or creation of the table ever fails, it'll tell us why, which is going to be very useful for us. Cool. Now, let's create a delete task table. We're not actually going to be using this, but this is just for demonstration purposes as to how you could do it if you ever need to do this. So I'm just going to quickly go through this. Using SQL, deletes a task table. You can do self.con.execute. And this command is pretty short, so we can just put it in a single line. Drop table if exists. Semicolon. Cool. Does everything make sense so far? Awesome. All right, next, let's cover how we can get all tasks in a table. Get all tasks. This is also very similar to our previous commands, where we can just do self.con.execute with our SQL command inside. But there's a little gist, so let's talk about what that little gist is in a sec. Gets all tasks in the tasks table. Cool. So let's do self.con.execute. Select all from tasks. tasks. So does anyone see an issue with this? If you don't, it's that where exactly is the output of this being stored, right? We don't have like an output variable that we're storing it into, so we'll have to make that. So let's do cursor equals self.con.execute. And I'll actually explain why this is called cursor. So you can think of this variable as analogous as your cursor on a Microsoft Excel or a Google Sheets document. So I actually have a Google Sheets thing open right here. And if, let's say, right, we have our cursor right here, it's analogous to doing this with our cursor. So it's going row by row and selecting each of them one by one. So you can think of it that way. So yeah, so that's what cursor contains. It contains rows one by one at a time. So it's, in fact, a 2D array that contains all our rows and all the information in each of those rows. So we have to extract this. We can't just dump return cursor right now because this isn't a type that Python understands. So the way we parse this is, first, let's initialize a task list, right? If you remember from demo 1, we returned a list of tasks whenever we did get all tasks. Then we can loop through every element in the cursor for row in cursor. So again, cursor is a 2D array, and each element is a row, each element being this, and this, and this. And we can extract the information by doing tasks.append, right? So this is to add to a list. And if you remember, tasks was always a dictionary with ID having that being the ID, the description, and then the done. So what exactly goes into each of these? Well, it's a 2D array, and each row contains information in that entire row. So we can just index whichever element is the corresponding like information that we want. So like this is the first element in the row, this is the second element in a row, and then this is the third element in the row. And then we can return this list. Now, one quick thing. Recall that done is stored as an integer, right? So it's stored as either a 0 or a 1, 1 being true and 0 being false. In Python, we can actually wrap this in bool. And this allows us to change ones to true and zeros to false. In Python, in the context of integers, zeros will always be false, and any other number will always be true. That's just like a little Python quirk. If you really want to, you can just do something like, if row 2 equals 0 or if it equals 1 and set it that way. But yeah, just do this if you're used to Python. So now that we made a get all tasks function, let's actually see if we can hit this endpoint, right? So we haven't defined the endpoint yet, but we can actually go ahead and do that right now with this function being done. So let's go to app.py. I'll actually leave the db.py open for you guys to see it if you guys forget, or if you're still copying it down. So for get tasks, we want to call this function that we just created, get all tasks, right? And the endpoint we hit is /tasks. So let's actually make a comment, endpoint for getting all tasks. And let's do return json.dumps. Again, this is how we format our output. We specify it's going to be in JSON format and do tasks equals db. Oh, wait, oops. OK. One thing I forgot to do is initialize a database driver. So the database driver is this object that we created just now. Again, this handles with reading and writing data with the database. Yeah, so we have to initialize one of these. And the way we do that is by doing db equals. We have to import Actually, I keep forgetting to import a few things. We have to import JSON like we did with PA1. We have to import DB. This allows us to access any elements in the db.py file. And we have to, from Flask import request. So you'll see why you need this. Request is to get the body of the request from the client. We did this one in PA1 as well. So hopefully you guys are familiar with this. So next, let's create an instance of our database driver. So the way we do that is do db.databasedriver. And in this db.py file, we actually have to do DatabaseDriver equals singleton DatabaseDriver. Database. So this is invoking the singleton function that we created earlier. And this ensures that we only have one instance of a connection to our database. Yeah, so that's some setup that that you should do before you go ahead and call these functions. So let's call the function. Phew, that took a while. So let's do get all tasks, being the function we just created. And then let's return with a success response of 200. So the status code goes after the JSON.dumps. Again, recall demo1. Let's go ahead and test this on Postman. Let's create a new collection. Let's call this demo2. And let's make a new request. Let's call it get all tasks. And we can actually go ahead and run our app in. If you've activated a virtual environment in a different terminal, you can just run it from there. But I'm going to go ahead and do it in the VS Code one so that I don't have to keep switching between tabs. So with our virtual environment active and with us in the source folder, let's do Python 3 app.py. And now our server is active. Cool. Okay, hold on. Sorry, I was testing with the task table earlier, so I actually had to invoke that so that all the data gets cleared. But with that out of the way, wait, did I? Okay, with that out of the way, let's hit the endpoint localhost 5000/tasks. Oops. Cool. So our response is formatted just like it's formatted here, but obviously we have to check if this works, and we can do that by inserting data into our table. So let's move on to the next method to implement in db.py and app.py. Is anyone not done copying this part? I can close it for now. Okay, go ahead and close it right now. So let's create a new function. Let's call it insert task table. And the comment will be using SQL, adds a new task in the task table. So, all right, does anyone remember the command to insert something into a table? Any volunteers? Yeah. Insert into. Next keyword, anyone? What's the name of our table? Tasks, yeah. And then we want to specify the fields. Oh, yeah, the columns, right? Description done. Values and then the values we want to insert. Now, we know that the values we want to insert is, we can't just specify it into this command, right? We have to probably store it as a variable and put it into this command so that we're not like storing the same, or we're not pushing the same description every time. We're actually retrieving the request body and getting the description from there. So description actually has to be passed into us, and done also has to be passed into us. And with these two variables defined, we can actually put them as part of our SQL query. And the way we do that is a little syntactic, and you guys have to remember it, but it's going to be question mark, question mark. So question mark represents whatever value you're trying to insert externally. And to specify whichever values we're inserting externally, we have to have a comma after the SQL query, and then specify what those values actually are, which can be done by doing description done. So we're passing in the description and done to the function, which is being inserted into the SQL query. Now, the next thing we have to do is self.con.commit. What this does is it essentially saves the changes we made to the table. So we inserted a new object. We want to save that change, so we do self.con.commit. That's what commit does. So in fact, we're going to be doing self.con.commit for updating a task and deleting a task as well, because those are changes made to the table. Finally, we have to return the ID of the task that we just created. So, if you remember from demo 1, we returned the task that we created whenever we made one. And the way we do that is by doing return and some ID. Now, how do we get that ID? Well, if you remember from this earlier command, we can actually assign the value of this to cursor. And cursor, again, contains a result of the query. And cursor has this field called last row ID. And this actually specifies this actually just returns the last row that was added and the ID of the last row that was added. Yeah. So just quickly going over what this function does. It takes in a description. It takes in either if it's done or not. It'll insert that into the task table. It'll commit that change, and it'll return the last row that was added, which is the task that we just created. So let's invoke that in our app.py. Come on. I'm just gonna. Okay, it's being very uncooperative. Okay, I'm just gonna do it here. Hopefully you guys have it copied down. Okay, so this is the endpoint for creating a task. We're creating new task. And this follows the exact same format as demo 1. So we do body equals json.loads request.data. This takes in the request body, and we can extract the description of it by doing body.get description. We can extract. Okay, and then we can extract the. Oh, okay, yeah. Then we call the command that, or sorry. Then we call the function that we just created, insert task table. We can do db.insert task table. And again, we have to specify the description, and we have to specify if it's done or not. From demo 1, we said that if we're creating a new task, we're just going to assume that it's not done by default. So we pass in the description, and we pass in false. And if you remember from the db.py function we just created, we returned the last row ID. So we want a way to store that. And to do that, we can do assign it to a variable. So task ID equals db.insert task table. And this stores the output of the function we just created. So this isn't actually done yet, right? We want to be able to retrieve the task we just created so that we can return it as a response as part of a response body. But we don't have a function for getting a task by its ID. So let's make that, and then let's call it using this task ID that we just created. So let's make a new function. Let's call it get task by ID. Right, we want to specify the ID, so that's why you pass it in here. And what it does is using SQL gets a task by its ID. Cool. So we can actually copy the syntax from get all tasks. It's very similar to that. We're just returning one of the tasks, the one specified by the ID. So let's make a few changes. So the way we specify conditions in SQL is again by the keyword where ID equals, and we have to feed it a question mark because that's values we're injecting externally. And followed by this is the value that we want to actually pass into the SQL query. Now, one thing to note, this library actually expects tuples, which are basic, kind of like arrays or lists, except they have a set size. And the way you you have a tuple in Python is if you wrap the elements in parentheses as opposed to like say square brackets or curly brackets. Now, this is not actually a tuple. It only has one element. So to specify that you want to make it a tuple, this is just something you're going to have to memorize. You have to put a comma after the first element. This tells Python this is a tuple with one element in it. Cool. So now we do for row and cursor. Again, the cursor drags across each row that we have in our Excel sheet. And we retrieve the task information that way. Now, since we did select a star from task where ID equals question mark, and again, IDs are unique identifiers, we're only going to have one element in the cursor. Does that make sense? We only have one element because there's only one element with that ID. So we don't actually need a list of tasks. And we can actually just go ahead and return the first object that we see. And if, for whatever reason, we don't find the first object, that probably means the task was not found, in which case we can return none. Cool. Questions so far? OK. So let's call this function we just created, right? So we have the task ID of the task we just created, and we want to actually get that task object. So the way we do that is by doing task equals db.get by task by ID, and just pass it the task ID we created. Then we can do if task is none, right? So we can potentially return none from this function. But that shouldn't actually ever happen because we just created this task, we retrieved the ID of that task and we retrieved it. So if this condition is being met, something severely went wrong. And we don't actually know what went wrong, so we'll just return error, something went wrong while creating a task. And 400 for failure. But if we have found a task, we can just go ahead and return the task right away. So we'll do return JSON.dumps task, and then a successful creation, so it's 201. So let's go ahead and test this on Postman. Let's create a new request. Let me zoom in on this too. Let's do create new task. make it a post request. And the URL is localhost 5000/tasks. Localhost 5000/tasks. The body of it, right, we can specify like such, and we'll do, let's just follow the Google Sheets I made. So give demo2. The task I want to do is give demo2. Let's go ahead and send this. And you can see that the task object was returned to us. I'm assuming this is where a lot of people might get a few issues. So if you do, feel free to raise your hand and the TAs will come to help you. So we just created a new task. Let's check that our task was actually added to our database, our table, by doing get all tasks. And you can see here that our task was successfully added to the table. When we do get all tasks, it gives us the task that we newly created. Let's make the second one too. Edit demo2. And let's get it. Or let's get all tasks. And you can see that the second one was created as well. So this is working cool. Okay, so the remaining two endpoints we'll cover are going to be update task and delete task. So let's do that. Oh, there's a get task. Get task is actually very, very simple. We just created a function that gets the task by its ID. So we can just go ahead and copy this last part of the create task function, paste it here, right? So it retrieves a task by its task ID by calling this function that we created. If the task is none. Now, this is a slightly different case than the earlier one, because the earlier one, logically, it should give us a task. But this time, it just means that the ID was invalid, meaning we can change this error message to task not found, and change this to a 404 error, and also change this to a 200 error, or 200 status code, because it's not a successful creation. Let's make the comment to this. Endpoint for getting task by ID. Finally, these last two, update task and delete task. So let's make the functions in db.py first. So let's have def update task by ID. We'll pass in the ID, the description, and if it's done, right? So this is how we update the fields of our task. We feed it the description and if it's done or not. I'm going to say pass here just because I want to define the delete function as well. Delete task by ID. And this we only need the ID because we only need the ID to know which ID we want, or know which task we want to be deleting. So update task by ID is going to be very similar once again. So using SQL, updates a task by ID. And we'll do self.con.execute update task set description equals question mark, done equals question mark, where ID equals question mark, semicolon, do not forget that, description, done, ID. So this is very similar to what we've previously covered. So it's just running another SQL command. So this is more a question of like, you know, the SQL query syntax, in which if you don't, you can just refer back to lecture. So I won't be explaining it too much, also because we're running a little bit low on time. And finally, again, when we make changes to the table, we want to commit those changes. Think of it almost like saving, like a file or saving the changes that we just made. So we'll commit those changes. Let's go back to our app.py. Come on, split screen. Okay, nice. I'll leave this here for those who weren't able to copy it fast enough. Let's put it here. And we'll do endpoint for updating task by its ID, All right, so let's retrieve the request body. This is the same as demo1. Description equals body.get description done equals, right? We have to convert this into a body.get done. And we'll call the function, we'll call the function that we just created, db.update task by ID. We'll pass in, right? The only thing, the things it requires are the ID, the description, and if it's done or not. So we'll pass in the task ID that's provided to us from the URL, if it's the description of it, and if it's done or not. Finally, if the task was successfully updated, we can retrieve that. db.get task ID. And if it doesn't exist, then the task was not found. And if it was successfully retrieved, then we can just return it with the status code 200. So hopefully this logic makes sense. This is just retrieving information from the request body. We're calling the function that we just created. We're retrieving the task if the task actually exists. If it doesn't exist, we'll throw an error. And if it does, we'll return a successful response. So let's test that as well. We have give demo2 and edit demo2. So let's go ahead and add a request called update task. Make this a post request. And localhost 5000 tasks. And if you look here, we have to specify the task ID, right? So let's say we want to change give demo2, which has the ID 1. So we'll put that into URL. And in the body, we have to specify the new description and the new done field. So description done. Let's say the description is still give demo2, but now we're done. Well, we almost are. So I'll change this to true. I'll save the request. I'll send it. Oh. Up the pipeline 49. JSON.loads. Loads, sorry, miss an S here. No such table task. Oh, tasks. Stop missing those S's. Okay, nice. So we updated the description, or we updated the done to true. And if we check back on our get all tasks endpoint, we can see that this was updated to true. Let's try editing something else. So let's do prepare for lecture 3. Let's send that. And if you go back here, you can see that it got updated. Finally, super quickly, delete all task. SQL deletes a task by ID. This is, again, just SQL syntax that you can refer back to lecture for, but it's delete from tasks, where ID equals question mark. And again, it's a single element tuple, so we have to put a comma after the first element. And then we'll do self.con.commit. This to save the change that we deleted this task. Let's go to our delete task function in our app.py and simply we're deleting the task by ID and simply call it. So db. Well, first of all, we have to return the task that we newly created. So we'll retrieve the task first. And if that task doesn't exist, then we'll return the task not found error as usual. And then if it is found, then we'll delete the task by its ID, being the task ID again, which is provided from our URL into our function, into the body of our function. And if it passed this if statement, it implies that the task was found. So we can go ahead and return json.dumps task 200. Cool. So let's go ahead and test this. Add a request, change this to delete task by ID. Let's delete the first task, right, with ID 1. If we send this, you can see the task that did get deleted, which is the task with ID 1 as we specified. Let's go to get all task, and you can see that that task is actually gone. And super quickly, so one thing that you guys might have noticed is that if I stop this server and I run it again, the task that I had before persists. So this is different from PA1 or Demo 1 in that we created a Python dictionary and we specified hard-coded values every time we started the server. So that meant that any data that was in your Python dictionary got deleted and got wiped every time you stopped the server. So this is a great thing about databases, that data persists and it stays there, right? So yeah, just conceptually know that that's another advantage of that's one of the advantages of databases. Cool. With that out of the way, we'll be doing the Kahoot.